There it is. Recording is started. Alrighty, so we were getting into 2.1, which is, come here, getting into 2.1. Oh, there it goes. Okay, and which was plotting stuff, Cartesian coordinates, which is mostly plotting stuff. So 2.1, this is the, if I spell it right, the Cartesian coordinate system. And so the point of this system was to be able to talk about points on a plane. And so we have a singular point, an ordered pair x, y. I did write down the fancy words for these guys, and then somebody's here, so I need to take note of it. Mr. Tharp is here. Alright, hold on a minute. Alright, Mr. Tharp does not need to be making noise. I think you can unmute yourself if you have a question, but we don't need to hear you moving around wherever it is you are. Okay, good. Back here. And so I had a fancy word for what the X was called, but I don't think I spelled it right. Let me go see if I spelled it right. Absika? And ordinates. If I get the space in there. Grab that. Now bet you. There we are. The fancy words. Nope. Don't go there. Go back one. So the fancy words that is possible to come across is the abscissa and the ordinate. The book is not using fancy words from Latin, is quite happy to call this the first and second coordinate, I believe. Yeah. The book is quite happy to not use the fancy Latin, so this is the first coordinate and the second coordinate. Or, if you prefer, you can also call it the x coordinate and the y coordinate. I don't really particularly care. I just want you to be aware that people get fancy from time to time because they think fancy words make them sound smart. And so there's going to be those jackwagons that think those fancy words mean more than they actually do. It makes them sound like a jackwagon, not a human being, or at least not a English-speaking human being. Anyhow, so we now have x, y, so we can now relate these guys to each other, and so we can write them down with equations. The first kind we want to do is the same plain old simple linear equation, which is something like an ax plus by is equal to c. There's pluses and minuses to this one. Somehow this is called the standard form. We'll get into that in, I think, the next lesson. But they have provisioned this particular equation for us. In particular, they have provisioned 2x minus 5y is equal to 10. All right, well, how do we plot this thing? So given an equation, how is it plotted? How to plot these guys? Okay, well, the nice thing about straight lines is that you only need 2 points to define your straight line. So when what usually happens is we pick an x or y value and solve for y or x as according to whatever you've left over. 2, we will repeat step 1 for several values, and then step 3 we plot the points that we have done. Plot points in 1 and 2, and then 3, that's not 3, 4, we can count. Step 4 is then play dot to dot. Okay, so this lovely plot here, that lovely equation, we'll go ahead and make myself an xy plane. Okay, so y goes there, x goes there. Linear equation only needs 2 points to define our line, so we will go ahead and make that. So it is convenient to pick integers, zeros, ones, things like that. So I'll go ahead and pick. I'm going to do 2 points, x equals 0, and y equals. Let's see here. Let's actually make a table of these guys. I want an x and a y, and make a table of it. I'm going to do an x at 0 and a y at 0, and then that will be enough. So then we have that. Okay, so 2 times 0 minus 5y is equal to 10. That goes away. Divide the minus 5 to the other side. Therefore, y is equal to 10 over minus 5, which is minus 2. So that's minus 2 there. And then go the other direction. 2x minus 5 by 0 is equal to 10. That goes away. And divide both sides by 2. So now I have that x is equal to 10 over 2, also known as 5. So we put a 5 over here. Okay. So that's enough to say that I need 5 lines up. 1, 2, 3, 4, 5, and 2 lines to the left. 1, 2. So I got a point here and a point there. And so I believe if I tap that point there, and then I hit shift. There we go. There's a one straight line go that way, and make it go back more this way. There we go, close enough. Arrow go that way, arrow go that way. There is our line. Nice and straight as according to what we need. So that's how you do a line. Those are easy, simple, not hard to worry about. Not hard to think about. The problem is what happens when you don't have a line. I'll keep that. Thank you. Thank you for that announcement. I will go ahead and get rid of this guy. We do not need that anymore. We have done our nice straight line. So next up we have, I'm going to wait on that one. I'm going to do C next. We have a parabola. Parabolas are very common things we have to plot from time to time. Y is equal to x squared minus 2x. Okay. So, what are we going to do with this guy? The way I recommend doing parabolas, which are, like I said, very common, is to factor them first. I think you should factor them. Yeah, you don't have to factor them. What you want to find points about the parabola that are very important. In this particular case, in particular, you would want to find the zeros of that parabola, if it has any. This one has some because I can factor it. So I factor into x, and x minus 2 equals 0. And so I find that x is equal to 0, and x is equal to 2. Based off of, basically I set y to 0 and then solved it, and so now I have 2 points from that. I now know that the point that is known as the vertex, basically the point where it turns around, is halfway between these two, so that's 1. So I'll also want to know about that. And then I'll probably do 1 on either side of the 0 of these two zeros as well. So I have that x and y. I know that x at 0 is equal to y at 0. I know that x at 2 is equal to 0. I know that I'm going to want 1, and since I think it would be appropriate to get minus 1 and 3 while we're looking at it. So what we have from that, we have 1 is in the middle, so we have that 1 squared minus 2 times 1 is equal to 1 minus 2 is minus 1, so we put the minus 1 there. Notice that this point is 1 below those, so I immediately know, because I know the parabola, that these 2 points here are 2 above this one here. So this should be a 2, and this should be a 2. I know it's symmetric about 1, which these 2 points are. 2 points away from 1. But I'll go ahead and show that I think we'll do 3 into here. So we have 3 squared minus 2 times 3 is equal to 9 minus 6 is equal to, really? Yeah. Huh. Apparently I am being a little dumb. And so these are extra 3's. I'm going to double check the minus 1 on that. Minus 1 squared minus 2 times minus 1. That is 1 plus 2. Yep. 3. Yep. Okay. Alrighty. Well, apparently it goes up 3 instead of up 2. Alright, whatever. Probably should have known that. Because these are 2 points, 2 units to left and right of our vertex here. And 2 points away, you square that and you get 4. So this is 4 point. These are 4 above our lowest point here. Anyhow, down 1 here, and we're going to go up 3. 1, 2, 3. And we're going to go left 1 and right 3. 1, 2, 3. 1 minus 1 is here, there, and there for the zeros, and then here and here for those guys. Let's see if I can do this. I bet I'll bugger it all. Ooh, I think I got it. That's not too bad. That's pretty good for parabola, free-handed. That's not too shabby. All right. So that's how you do a parabola. They all kind of look like that. And for parabolas, I do recommend you find zeros if they exist. I also might recommend that you also find the vertex, which is negative b over 2a, or the average of your solutions if you have them. These guys will probably be, these 3 points, assuming they all exist, are going to be very helpful points to know about. Also, in this set of things you could probably try, you should probably also do x equals 0 and see where that's at. But given that our constant here, our constant was 0, we already had it, so we weren't going to get more information by doing x equals 0. That would be the y-intercept. And so x-intercepts, your solutions, and your y-intercepts are some of the more important the most useful points to be plotting. Anyhow, all right. Do we have any questions yet? We all good? Neither hearing nor seeing any questions, I will go ahead and continue on with make sure it's recording. Yep, still recording. Very good. I will go ahead and proceed to the next plot it has for us. Let's go ahead and back that up to where I wrote down the parabola. Come on. Whee. Okay, boink, 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 and where the parabola that I wrote down. Because the next one we're going to write down is a different conic section. So, parabola is a conic section. Another conic section that you can come across is the circle. Y is equal to x squared minus, nope, not that one. That's parabola. Sorry. Next one is x squared plus y squared minus 6x is equal to 0. Alright. This is a circle. I know it is a circle because I have an x squared and a y squared, and they don't have numbers in front of them, and they're being added together. If this was a difference, that would be a hyperbola, and I don't know if I'll do any of those, but this is definitely a circle. There are tricks for being more efficient with our circles. I don't know if the book wants to do any of those. Quotation marks on, of course, yeah. Quotation marks on tricks, but I do not see that the book is particularly interested in doing those particular tricks. So I will not do them either, or as I don't think we will. Alright, well, in this case, I find it handy to solve for y. So I'm going to move the x squared and this 6x to the other side. Y squared is equal to negative x squared plus 6x. And then we're going to take the square root. So y is equal to the square root of 6x minus x squared. I am... Hold on. It would be handy to know where the 0 is, so that we're not off in La La Land trying to plot things. So it would be handy to know that. So I'm going to go ahead and do, so we basically have a parabola, something that looks like a parabola on the right side, but the left side of it says it isn't. And so I'm going to, but the center, I believe, should still be located at the same spot. So that should be negative b on 2a. So that'll be minus 6 over 2 minus 1. So that's at 3. So this looks like an important location to be considering. X and y. Alright, well, let's see where 3 is. Oh, and when I took the square root there, that's a plus or minus. So we're looking for y is equal to plus or minus the square root of 6x minus x squared. Starting off with 3. Okay. So we have plus or minus the square root of 3 of, go ahead and write down 6 first. 6 by 3 minus 3 squared. 6 by 3 is 18, minus 3 is 9. Sorry, 3 squared is 9. So 18 minus 9 is 9. The square root of 9 is 3, so this is plus or minus 3. Oop, don't move that around. Okay, I don't want to move things around. Plus and minus 3. Okay. Going out from there, I'm going to try 2. Right, so we got it 2. We have that y is equal to plus or minus the square root of 6 by 2 minus 2 squared is 4. 2 by 6 is 12 minus 4 is 8. The square root of 8 is 2 roots of 8, which is not very helpful. So I'm going to go ahead and ask my calculator for that. 12 minus 4. 2.82. So this is approximately plus or minus 2.82. is exactly equal to plus or minus 2 root 2. I would like to know the actual decimal version of this so I can write it down right. 2.82. Alright, well, if 2 is on one side of 3, then I should probably check the other side. That'll be a 4. Alright, so y is equal to plus or minus the square root of 6 by 4 minus 16. 6 by 4 is something. 24. 24 minus 16. 24 minus 16 is also 8. Oh, interesting. So this is plus or minus 2 root 2 because this is 8. Oh, okay. Plus or minus 2.82. So I have indeed found the middle of this. So now I need to go left and right of that. So I'm going to go more to, so actually instead of writing 4 there, oh, bugger. No, don't do that. No. Put everything back. Alright, it's back up to here. Instead of putting 4 there, I'm going to go ahead and put 4 up here. Nope. Drop it, thank you. And I need the pencil back. So 2 and 4 go there. I'm going to do 1, and I believe on the other side of 1 is going to be 5. And then I'm going to do 0 and 6. And that should be enough. Alright, I also need to get a little more space in here. How doing for time? I'm doing splendidly. Alright. There we go. Alright. Who's up next? 1. We'll do 1 now. Plus or minus the square root of 6 by 1 minus 1 squared. So 1 squared is 1, 6 by 1 is 6, 6 minus 1 is 5. So this is plus or minus the square root of 5, which is approximately 2.24. 2.24. So plus and minus 2.24. And then this guy here, last one, y is equal to the square root of, oops, I'm getting a little ahead of myself there, plus or minus the square root of 6 by 0 minus 0 squared. Oh, well, 6 times 0 is 0, minus 0 squared is still 0, so the square root of 0 is, well, that's just 0. And 0 is not signed, so 0. Unless you're working floating point, in which case that's a whole other story of how floating point works. Okay, 0. Okay, so what appears to have here is a circle that is has a diameter of 6 or a radius of 3 and is located at 0, 3. Okay, well, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. Got a point there, got a point here, up 2.25 is there. Oh boy, down 2.25. Yeah, all right, about there. 2.82 is about there, and there, and then 3 is there, and there, and then come back down the other. Oops, that's not very good. Try that again. There, and there. Yeah, this is definitely not square. That's all right. Yeah, my vertical axis is definitely not the most, does not bring joy to analytical geometry, I can tell you that. So a circle looks like something like that. That's a terrible looking circle. Alright, okay. Alright, so that's all well, lovely, and good. I'm not going to do that. I'm going to remove the contents of a screen. And delete that. There we go. Oop, missed a little bit. Delete that there as well. Thank you. And tap there. And let's flip forward to the pencil. All right, so we have plotted things. Now I would like to know. I'd like to know some things about 2 points. So if I have 2 points, x1, y1, and x2, y2. On occasion, I'd like to know something about these 2 points. The first one I'd like to know is distance. Distance. All right, well, distance between these 2 points. So there is, if we, let me get a, see if we can't make a proper triangle in here. That guy, come on, tap there. And then, I believe, yep, there we go. Constrain to horizontal. Constrain to vertical. And let go of that. And come back to the original point. Oh. Come on. There we go. All right, so on one end I have x1, y1, and on the other end I have x2, y2. And I would like to know the length of this line. Well, if you know anything about our friend from Pythagoras, suppose this were just simply x1 going that way, and we have y2 going that way, and so that this is 0 and this is 0. So, well, we know from Pythagoras, which I have proven to myself at least once, that the length up here is the square root of x1 squared plus y2 squared. As if these were on the axes. They aren't necessarily on the axes. They can be anywhere they like to be. And so, so the question isn't, in order to make this more useful to us, we can just do a difference, delta x and delta y. And so the distance, if you go to a physics course, you're going to find it written as delta x squared plus delta y squared. And if we need more dimensions because we're in 3D, delta z squared. If we are being absolutely abysmal to ourselves and have more dimensions than that, and we are pretty certain we're in Euclidean space, then you end up with the square root of the sums of delta xi quantities squared under the square root there, like so. That's the fancy way to do it. If you've got lots and lots of dimensions, we won't do that. The most we will do is 3, and so this is plenty for us. If we need a little more written out, you end up with the square root. I believe the book has written it all the way out, hasn't it? It has indeed. The book has indeed written it all the way out. So we have x1 minus x. Sorry, not that matters, because we're squaring things. X2 minus x1 square plus y2 minus y1 square. This is the distance, the length of this line here. Well, on occasion, we also want to know where the middle is. Right there. Where's that? And that is the midpoint, which is basically the average position of 2 points, is what it is, mathematically speaking. So it turns into x1 plus x2 divided by 2, comma, y1 plus y2 over 2. Or repair like so. I believe the book has kindly provided several examples of this to us. It has, sort of. we're going to do both of those for the points 5, 1 and -1, 3. Okay. So what's the length of the line between those guys? Well, Pythagorean equation for a distance, the square root of 5 minus -1 squared plus 1 minus 3 squared. All right. So that means that we have 5. This between 5 and -1 is 6. So the square root of 6 squared. Plus this is between 3 and 1. That's 2 squared. So that is the square of 6 is 36. Plus the square root of 2 is 4. So that gives us the square root of 40. I got a factor of 2 in that. Factor of 4, and pull that guy out. So that it can reduce down to 2 root 10. That is as far down as I would go without making any simplifications. If you need a decimal answer for reasons, that is 2 root 10 or 6.32. 6.32. It would be handy if these guys had lengths on them, so we can actually say these are meters, but it is not necessary for your coordinate system to be given in meters. On occasion, you can plot lots of quantities against each other, which means that you can get some funny units of length, which gets really weird when you're trying to do the distance between 2 points and they aren't the same kind of unit, which means you need to figure out what it means to be combining those units together, because there's not a standard way to do that. Fortunately, for this class, that will not be a problem for you. In your everyday life, that may be a problem. I hope you don't have that. I don't think that'll be a problem in most businesses, but it could happen. I had to yell at a bunch of people on there's a mathematics version of what's it called? Markdown? I forget what forum is called, and it's had the mathematicians go there going, units do matter. Anyhow, so we have 5 plus -1 over 2, and and 1 plus 3 over 2. And so in this case we have 5 minus 1 is 4. 4 over 2 is 2, and this guy here is 1 plus 3 is 4 over 2 is also 2. So there's our midpoint for these guys. So if I were to go plot them, which I should do to demonstrate that this works more or less, that's what we got. We need to go a little bit to the left and a lot to the right. -1, 1, 2, 3, 4, 5, and up 3. 1, 2, 3. We got this point here, and 5, 1 is over here, and the midpoint is about there. Yeah. Again, we another Cartesian plot coordinate system that is not bringing joy to analytical mathematicians, because that didn't quite match the point, but considering doing that by hand, that's not too shabby. All right. So, time is 40. I got 10 minutes. All right. Let me show you some other things here real quick. Like, let's see here. I would like to take this guy. Can I alter it? Properties, select window. I'm going to point it here at you guys for a hot minute. Alright, and I'm going to show you something slightly different. Because the book wants to show something different here. So it is not necessary for you to do these things by hand if you are so inclined. Let me see here, make sure that good enough. So if you want to do things more properly, you can go to, say, Desmos, I believe, if I spell right, desmos.com. I would like to graph things. So if you wanted to, you can go to, say, Desmos and ask it to plot things like 0.1 x to the 4 plus 2.2 x to the second minus 2.4 x plus 4.5. All right, so there's that guy, and I believe that's correct. Minus 1 minus 2. Oh, minus 2.2. That's why. Let's drag that one. There we go. Minus 2.2 plus 2.4. Oh, plus 2.4. There we go. Now we got what they've drawn. Okay, so we have this guy here, and so if you need to, you can say go to Desmos and have them plot it. Alternatively, so Desmos' plotter is really pretty good. I have no complaints about that. I think, if I remember, I believe I can ask it for the circle that we had. Minus 6x equals 0. There we go. So there's our circle. There's the actual circle that that was aiming for. This guy right here. So you can see it's centered at 0, 3. Sorry, 3, 0. And has a radius of 3 going all the way around. And that's a very nice circle there. Alternatively, we can also go to Wolfram Alpha. Go ahead and leave the page. And you can ask it to also plot, let me write it down again, 0.1 x to the 4 minus 2.2 x square plus 2.4 x plus 4.5. Tap that, and it should produce. That's not too bad. I think Desmos looks a lot nicer. That's for certain. But it will get the job done. I can't complain about it too much, but there it is. If you need to specify other things like for x between minus 5 and 5, you can do that. And you get this kind of thing, so you get that stuff there. And you can also ask it to plot, say, that circle again. So you can say y squared, plus x squared plus 6x equals 0, and it should produce. I think I put in the. There we go, and there's our circle. So you can, as you see fit, you can plot either. Oh, I didn't change the shared screen. Sorry about that. Because I was recording this, I intend to, and I'll put it up to my YouTube channel shortly. You can go watch me use Desmos and Wolfram Alpha to make plots there that we had previously. So those are also options for you if you are so inclined. You may have access to a graphing calculator, and the graphing calculator will also do a reasonably good job of plotting things. You will need to be aware that the way that most graphing calculators work, if you have one, is that it will only plot a point for things that are on the x-axis pixel. If there is not an x-axis pixel for it to plot that point, it will not plot it, which means that you may have artifacts in your plots on your graphing calculator. So if I took that circle and I plotted it on a graphing calculator, more likely than not, the 0 would be a point, and so it would hit that point correctly. more likely than not, 6 would not be one of those points, and it will have a gap on the right side of that circle. If you're trying to divide by 0 somewhere, more likely than not, you will end up, that division by 0 will not be one of the pixels. And so you'll get a vertical line going from somewhere on the left side to somewhere on the right side, and you'll not truthfully reproduce those particular plots. So there are some things you need to be aware of when you're plotting things on your graphing calculator, if you have one. As noted, it is not required for this class, but I would highly recommend. It is beneficial to have one if you need it. Anyhow, at this point I am done with my thoughts, and so I will see y'all tomorrow because I had no problems getting down that hill. So see you tomorrow. Bye.